1.
No,
Yes, say.
no, we are having practicals on Thursday also.
No, no, dear. Wednesday we are having a class. On Wednesday we'll discuss that, we don't have class.
No, you said na कि Wednesday says so.
No, no, no. See, Wednesday so अपना lecture है, but Thursday तो we don't have. No, we have Monday,
yeah.
Wednesday, Friday.
Okay.
No, yes. Light chapter में anybody is having any doubt? Light chapter. In light chapter, anybody is having doubt? Avan, any doubt in light?
No, sir.
Okay. Right heading, electrostatics. So please write and keep everything. If you have doubt, now lectures may clear it. Don't be ashamed. But that is only possible if you have doubt accumulated with you. And everybody should complete the paper, submit it by today or tomorrow. This week you will get all your backlog papers. And those who can submit in the office, it will be the best for me. Then immediately I will correct and give. Electrostatics. Charges are quantized or not quantized?
Quantized.
What is meaning of quantized? Charges are quantized means what? It is due to loss or gain of integral multiple of electron. This is meaning of quantized. So Q is plus or minus NE. Charges obey law of conservation. No, law of conservation is obeyed by charges.
Yes.
What is meaning of law of conservation? Total charge of the system remains constant.
Constant.
So whatever is the charge at the start, Q1 plus Q2 is Q total. This will be always constant. Okay. Right, 2 points. तो पार्ट 2 तक अगर परफेक्ट कर लिया ना तो आपका एकदम सही हो जाएगा बाद में. March 4th is your board exam starting. So if I stop by February 20, this 15 days sufficient for you? Till 50, can I take revision? Till Feb 20?
Fine, sir.
I think this is convenient. Because when you will come for the lecture, now you will be on the toes. You will be prepared every time. This Sunday, you will have test on MCQ full length. Completed these 2 points. Shall I clear?
Yes, sir.
So, see, for whomsoever it is possible to submit the paper in the office, please do that. If you are submitting in the office, next day itself, you will get all the papers. So, what is force between 2-point charges situated in air? Force between 2-point charges situated in air? 1 upon 4 pi
4 pi
epsilon naught
Q1 Q2 by R square.
by R square. Correct. This is when 2 charges are in air. Force between 2 charges situated in medium will be Fa upon K. K is called dielectric constant or relative permittivity, epsilon upon epsilon
B
naught.
upon E naught.
Epsilon upon epsilon naught. What is value of epsilon naught? 8.85
0.85 into 10 to the
10 to the power minus 12.
minus 12.
Coulomb square per Newton meter square. And what is 1 upon 4 pi epsilon naught? 9 into
9 into 10 raised to minus 2.
Newton meter square per Coulomb square. If charge Q is split into 2 charges, Then for maximum force, what is Q1? Is it same as Q2? It is equal to half of total charge?
Yes, sir.
Okay, copy this point. So this week our target will be for electrostatics.
Done, sir.
If you complete, tell me.
Done, sir.
What is meaning of equilibrium?
Force is equal to 0 total.
Net force 0. So if we have charge Q and capital Q at center, for equilibrium, what should be capital Q? How will you solve? If this you call first charge, this is second charge, this is third charge. So can you say F12 vector plus F13 vector should be 0? That means F12 should be F13. Hello? So 1 upon 4 pi epsilon Q upon this I take R square equal to minus 1 upon 4 pi epsilon Q upon 2R the whole square. So 1 by 4 pi epsilon Q cancel, Q by R square equal to minus of Q upon 4R square. So capital Q is minus Q by 4. I hope you followed this also. Yes,
Yes,
follow
sir.
that. Okay, right. See that one sum I had given ratio of number of tons. So E1 upon E2 is N1 by N2. That is our transformer property for EMF. Many of you have written N2 by N1. Completed?
Done, sir.
Can you tell me what is net force at centroid of equilateral triangle if three charges are same? What is net force at centroid? Any of you are remembering? Is it 0?
Yes, sir.
If we have got charges at the corners of square, then how to find net charge at net force here? This will be repulsive force. F12, 13 is also repulsive force. F14 is also repulsive force. F12
Resultant.
is perpendicular to F1 force. Also, they are equal. So, resultant of F12 comma F14 will be root 2 times F12, and F net will become then root 2 times F12 plus F13. Clear? Those who have not submitted Sunday's paper, please submit by tomorrow. And if possible to submit in the office, as I said, that will be best option. But I'm not forcing, it is up to your comfort. Only the thing, if you are submitting in office paper, you will get next day only. Written?
Done, sir.
What is force acting on charge q when placed in electric field? Force on charge q when placed in electric field. Yes, what is formula? Is it QE?
Yes,
Yes.
sir.
Okay. If charge remains stationary in electric field, then what concept you will apply? Mg equals to electrical force. Yeah, right. All force related mostly I have given you everything. Now electric field related will be. Okay. Electric field due to point charge at distance r, comma E equals to 1 upon 4 pi epsilon naught q by r square. Right. When two charges are positive or negative, then electric field is zero in between, such that E1 equals to E2. When one charge is positive and other is negative, then electric field will be zero close to magnitude of smaller charge. Right.
Done, sir.
What is electric dipole moment? P equals to Q into distance between them. It is directed from negative to positive charge. Its SI unit is coulomb meter. Electric field at any point on axis of dipole, comma E equals to 1 upon 4 pi epsilon 2p upon r cube. Angle between P bar and E along axis is 0. Yeah. electric field at any point on equator of dipole is 1 upon 4 pi epsilon naught P upon R cube. It is directed from positive charge to negative charge. Therefore, angle between P bar and E equator is 180 degrees. Written 19.
Yes, sir.
At any point due to electric dipole, comma E equals to 1 upon 4 pi epsilon naught P upon R cube root of 3 cos square theta plus 1. Theta is angle between line joining point P and axis. And tan alpha is half tan theta. Okay, written this also.
Yes, sir.
Torque experienced by electric dipole, comma tau bar equals to P bar cross E bar, that is tau equals to PE sin theta. For zero torque, P bar is parallel to E bar. For maximum torque, P bar is perpendicular to E bar and P maximum is Pe. Right. Okay.
Yes.
Electric flux phi is integral of E bar dot ds bar, or it is charge enclosed by solid upon epsilon naught. Right. Then the electric field near charge sphere E equals to 1 upon 4 pi epsilon naught q by r square on surface E equals to 1 upon 4 pi epsilon naught q upon capital square at any point inside E equals to 0. Yes, completed. Written completed full.
Yes, sir.
For non-conducting solid sphere, let rho be charge per unit volume. Rho equals to charge upon 4 by 3 pi r cube at any point outside, that is small r is greater than r, E is same formula, 1 upon 4 pi epsilon q by r square, which if you want you can write as 1 upon 4 pi epsilon q is nothing but rho into 4 by 3 pi r cube upon r square. So this 4 pi will get cancelled. That will become rho r cube upon 3 epsilon naught r square. But I remember in this form, when required, we'll convert in rho form. Second, on surface is 1 upon 4 pi q upon capital R square. That can be written as rho into 4 by 3 pi r cube 4 pi epsilon naught into r square. 4 pi cancel. That will become rho r upon 3 epsilon naught. Right. This is slightly difficult wala formula. So if you remember basic, you can derive formula in exam. So point lies inside. Sphere of radius r. This is Gaussian sphere of radius small r. The charge is inside this. By Gauss's theorem, total flux is equals to q upon epsilon naught. Flux equals to E bar dot ds bar, which is same as charge inside upon epsilon naught. So E into flux through area 4 pi r square. This equals to q inside will be rho into 4 by 3 pi r cube upon epsilon naught. So 4 pi cancel from both sides. Therefore, E equals to rho into r cube upon 3 epsilon naught into r square. Flux to that surface to 4 pi r square. That will become E equals to rho r upon 3 epsilon. Just can I clear this third one?
Yes, sir.
field at any point near infinite line of charge or thin cylinder, we can say. Let lambda be charge per unit length. So E equals to lambda upon 2 pi r epsilon naught. Electric field due to infinite sheet of charge. E equals to sigma upon 2 epsilon naught due to infinite sheet of charge.
Done, sir.
Electric field near charge conductor, comma E equals to sigma upon epsilon. Mechanical force acting per unit area on charge conductor, comma force upon area is half sigma square upon epsilon, which is half epsilon into E square. Energy density or energy stored per unit volume, comma du upon dv, same formula, half sigma square upon epsilon or half epsilon into E square. Capacity of conductor, comma C equals to Q by V. Capacity of spherical conductor, comma C equals to Q upon Q by 4 pi epsilon naught R, so 4 pi epsilon 0 into R. Capacity of parallel plate condenser, comma C equals to AK epsilon 0 by D. One upon C series is 1 upon C1 plus 1 upon C2 up to 1 upon Cn. So for two condenser, product upon sum. If two condensers are equal, then C in series will be C by 2. C in parallel is C1 plus C2 dot up to C. Energy stored between plates of condenser, comma U equals to half CV square, half of QV, half of Q square upon C. Work done by battery to energy stored will be QV upon half QV, that is 2 by 1. In polarization E induced, E minus E induced, like this is E and this is E induced. E inside will be always E minus E induced. Okay?
Yes, sir.
Electric potential due to charge Q at distance R, comma V is 1 upon 4 pi epsilon Q by R. When N droplets combine to form single drop, then V large is N raised to 2 by 3 V small. Potential energy between two charges, comma, U equals to 1 upon 4 pi epsilon Q1 Q2 upon distance between 1 2. For 3 charges, U equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R12 plus Q1 Q3 upon R13 plus Q2 Q3 R.
Done, sir.
So that's all. Please revise everything so that when I start with MCQ, at least formula part you